Hello everyone, we are going to study today practical 3 to observe the following reactions and classify them into the types like combination reaction, displacement reaction, decomposition reaction and double displacement reaction. Now for that what all you have to take is reaction of water with calcium oxide, that is lime, then effect of heat on ferrous sulphate, reaction of copper sulphate with solution copper sulphate solution with iron nail, then reaction of solution of sodium sulphate with barium chloride. Then you have to take the apparatus such as 250 ml of beaker, china dish, asbestos sheet, dropper, hard glass test tube holder, test tube stand, sandpaper or burner or spirit lamp, filter paper. Now chemicals required are calcium oxide, water, crystals of ferrous sulphate, iron nail or wire scrubber, then solution of copper sulphate. Now this is calcium oxide. This is spatula. I am taking calcium oxide in a test tube. I am holding it with the test tube holder and I am adding little water to it. Now you will not be able to see in this, you will not be able to observe here in this experiment how it is taking place. That is, it is an exothermic reaction, but you will not be able to see it clearly over here because when you will touch it only you will understand. The first part of reaction, that is reaction of water with slacked lime. Take 10 ml of lime in a clean and dry china dish. Place this dish on asbestos sheet. Take a little water in a beaker. Using dropper, sprinkle some water on lime in a dish. Record your observation. What do you observe? Note the heat evolved or absorbed during the reaction by touching the dish. Test tube becomes hot, hence reaction is exothermic. Then note whether gas or vapor is given out. Colorless vapors are evolved. Then note the noise if produced during the reaction. It is exothermic reaction. Then huzzing sound is produced. Then note the changes in the physical state from solid to liquid. Now reaction is CaO plus H2O is equal to CaOH twice. Inference, it is an exothermic reaction. What is formed? Calcium oxide combines with water to form calcium hydroxide. Now we are going to study effect of heat on ferrous sulphate. Now you can see I am taking in the spatula ferrous sulphate. It is light green in color. I am taking in the test tube. This is a bottle of ferrous sulphate. So it's light green in color. I am going to heat it now. Now you can see water molecules are accumulating at the sides of the test tube. Now you can see water of crystallization at the side of the test tube and the white color substance is left behind in the test tube. that is Fe2O3. Now effect of heat on crystals of ferrous sulphate. Like this test tube and then burner you have to take crystals of ferrous sulphate, you have to take in the test tube, then you have to heat it, take 10 grams of powdered crystals of ferrous sulphate, clamp the test tubes to a stand, heat it with the burner for about 10 minutes. Note the color of gas evolved, do not smell the gas. Continue heating until the color of the substance in the test tube changes. Keep the hot test tube on the asbestos sheet. Observe the color of the substance in it after cooling. Now note the original color of the ferrous sulphate. It was light green in color. Then note the color of the gas evolved after heating, colorless gas. Then observe the color of the substance in the cold test tube and note it, that is reddish brown color in the test tube. Now FeSO4 is a name of the ferrous sulphate, that is 2FeSO4 7H2O solid state when heated gives Fe2O3 solid plus SO2 gas, and then water molecules evaporate. 14 water molecules evaporate. Those are called as water of crystallization. On heating, the pale green colored crystal of ferrous sulphate undergoes decomposition. Then decomposition and releases water of crystallization, then SO2 gas, and then reddish brown residue remains in the test tube. Color of the copper sulphate solution, it is blue in color, and this is iron strip which we are keeping it in the dipping it in the copper sulphate solution. Now you can see the next day the change in the color of the copper sulphate solution. You can see blue color of the copper sulphate solution is turned to grey color or brownish color after the reaction, and the strip also changes its color. Iron strip also changes its color, and you can see there is a coating on the iron strip. C part of experiment, reaction of solution of copper sulphate and iron nail. Now you can see over here before reaction and after reaction. Now see here, take 100 ml of solution of copper sulphate in a beaker, note the color. Then take 2-3 unrusted iron nails, clean them rubbing with sandpaper and wash it with the water, note the color of the nails. Keep the nails immersed in the copper sulphate solution for about 15 minutes. Observe the change in color of the nails and solution. Remove the nails from the solution after 15 minutes. Wash them and keep them on a filter paper. Note the change of color of nails and the solution. Observation table. Color of CuSO4 before experiment, blue color. Color of iron nails before experiment, grey color, steel color that is. Color of copper sulphate after experiment. Color of copper sulphate after experiment, it turns green. Color of the iron nail after experiment, reddish brown. What is the type of reaction? That is Fe plus CuSO4 is FeSO4 plus Cu. It is displacement reaction. On immersing the brown colored iron nails in a blue colored copper sulphate solution, they displace copper from copper sulphate solution, and then the color becomes brown or reddish color. This is called displacement. The next part of the reaction, that is sodium sulphate. You can see sodium sulphate also colorless, and barium chloride also colorless. Now we will take sodium sulphate. We are going to mix barium chloride. Now you can see the difference. Here white colored precipitate will get settled down after some time. You can see the color difference. This was a colorless liquid, barium chloride, then sodium sulphate. Now you can make out the change of the color. Okay, so this is a double displacement reaction where in this double displacement reaction, barium chloride plus sodium sulphate give rise to barium sulphate plus sodium chloride. So this type of reaction is called double displacement reaction. The D part of experiment, the reaction between sodium sulphate and barium chloride. Take 20 ml of sodium sulphate in a solution, clean the beaker, note the color and the nature. Take 10 to 15 ml of barium chloride solution in a test tube, note the color and nature. Then pour the barium chloride solution from the test tube slowly into the barium sulphate. Pour barium chloride solution into the test tube into the sodium sulphate solution in the beaker. Keep stirring in the beaker. Observe the changes. Now see the observation table. The color and the nature of sodium sulphate solution before experiment, colorless liquid which is transparent. Then the color and the nature of barium chloride solution before experiment, colorless and liquid which is transparent. Then the third, the color and nature of mixture resulting on mixing the two solutions into each other. White colored insoluble barium sulphate is formed. What is the type of reaction? Let's see. BaCl2 plus Na2SO4 gives you BaSO4 plus twice NaCl. Inference: in this chemical reaction, into new compounds are formed by mutual exchange of the components of the that is ions or radicals of the two compounds. Such reactions are called double displacement reaction. So in this reaction, insoluble, white color insoluble BaSO4 barium sulphate is formed. As a result, a white colored precipitate is formed in the beaker.